So problem 25, heights are normal with mean 68, standard deviation 3. What's probability that the height of an 18-year-old man selected at random is between 69 and 73? Alright, so this problem once again is a single normal problem. It's not a CLT problem. So what's going on is x follows normal with mean 68, standard deviation 3. They want probability x lying between 69 and 73. Standard stuff. Find the z-score. So the z-score for this is 1.67, and if you go to the z-table, that shall be 0.9525. The z-score for this is 0.33. If you go to the z-table, you shall find that's like 0.6293. So probability x lying between 73 and 69 shall be 0.9525 minus 0.6293, which shall be 0.3232. Compared to that, problem 26 is okay. So the first statement of problem 25 and 26 are same, but note that for problem 26, it's what's the probability that the average height of a sample of 10 18-year-old men will be between 71 and 78. So now it's no longer a single normal problem, it's a CLT problem. This is a CLT problem. So for CLT, once again, we need n bigger than or equal to 30, or population is normal. Do we have one of those? Here n is 10. So this is not satisfied, but this is, because are approximately normally distributed ... So mu is 68 and sigma is 3. So x bar follows normal with mean 68, standard deviation sigma by square root of n. We need probability x bar lying between 78 and 71. Obviously find the z-score for both. So it's 78 minus 68 divided by 3 by square root of 10, and this is 71 minus 68 divided by 3 by square root of 10. You can do 3 by square root of 10, you can calculate that beforehand, or you may not. You can put the whole thing in a calculator at the same time, and you shall find, you shall find them to be equal to so this one is 10.54 and this one is 3.16. Okay, so 10.54 is a large value. In fact, if you look at the z-table, it goes maximum up to 3.49, where it almost reaches 1. So for 10.54, you can say that this is 1. And for 3.16, you can look up the z-table, and that shall give you 0.9992. So probability that x bar lies between 71 and 78 is 1 minus 0.9992, which is 0.0008. Next problem. So 30 small communities in CT give an average of 138.5 reported cases of theft per year. Assume that the population standard deviation is known to be 42.6 cases per year. Find a 90% confidence interval for mean number of reported cases of theft per year. All right. So right off the bat, we know that this is no longer chapter 6, it's chapter 7. So chapter 6 was find the probability between this and that, like normal, CLT and all that. Chapter 7 builds on that. Chapter 7 is obviously related to chapter 6. It builds on chapter 6. But it's about confidence intervals. So how do we know that this is chapter 7? It says straight in the question. Find a 90% confidence interval. So, we don't have to look for more clues. Now, so here, okay, let's have a discussion. For chapter 7, let's have a discussion in a new page. For chapter 7, we did the following things. So there was like confidence interval for mu where sigma is known. That was one case, and there it was E equals ZC times sigma by square root of n, and it's like x bar minus E comma x bar plus E. The second was again confidence interval for mu where sigma is unknown. And here E equals TC times sigma by square root of n, and it's like x bar minus E comma x bar plus E. And the third thing we did was different. It was confidence interval for P, and there's no sigma. So there E was ZC times square root of P hat square root of P hat Q hat by N. And the confidence interval was P hat minus E comma P hat plus E. Now, what I'm trying to say is, it's you who have to determine which of these, we have to do. So that's another one of your jobs. We have a few more left to do. So this you shall not understand, but right now, unless we go through those chapters. So the other one was like two populations. The other ones will be two populations. a confidence interval for mu1 minus mu2, where sigma 1, sigma 2 are known. Here it shall be E equals ZC times square root of, I'm writing this with the full knowledge that we haven't done this, so you probably are not understanding what I'm writing about. But we shall cover this. We shall try to cover this as much as we can in the next class. So the confidence interval is x1 bar minus x2 bar minus E comma x1 bar minus x2 bar plus E. Again, two populations. This time, sigma 1 and sigma 2 are unknown. So confidence interval for mu1 minus mu2 E equals ZT times square root of, no, it's not ZC, I'm sorry, it's TC. S1 square by N1 plus S2 square by N2. And as usual, the confidence interval is x1 bar minus x2 bar minus E comma x1 bar minus x2 bar plus E. Here degrees of freedom is minimum of n1 minus 1 comma n2 minus 1, and obviously here degrees of freedom is n minus 1. And lastly, we have two populations. But now there is no sigma 1, sigma 2 and mu1, mu2. Now it's confidence interval for P1 minus P2. So E equals ZC times square root of P1 hat Q1 hat by N1 plus P2 hat Q2 hat by N2. And the confidence interval is P1 hat minus P2 hat minus E comma P1 hat minus P2 hat plus E. So for chapter 7, these are all the formulas that will be there. These are all types of problems. Now, obviously you have to know how to do each type, but a large part of your, large part of what you do should be to recognize the types. Like, given a problem, I should know, okay, this falls under this category. So let's do this problem. Now, for this problem, if you take a look, does it talk about first of all, is it like one population or two populations? One population or two populations? It is one population. So is it talking about mu, sigma, like x bar, mu, sigma, all those things? Or is it about p, p hat, all those things? So if you take a look, it's about these kind of things. And if that's true, then is it like sigma is known or sigma is unknown? Once again, if you take a look, sigma is known. So actually, sigma is known to be, assume that the population standard deviation is known to be 42.6. All right. 30 small communities in CT give an average of 138.5. So x bar is 138.5 and n equals 30. All right, now some of you may make the mistake of whether this is the n or this is the n. Now look, this average is the average of communities. So I mean, I hope that's like clear to you. Here each sample, so like okay, so what are we measuring? Reported cases of theft per year. Now that we don't measure for a single household, right? For this particular household, number of like reported cases of theft per year we don't measure. We measure this kind of things for a community. So for this community, what's the reported cases of theft per year? For that community, what's the reported cases of theft per year? And on and on and on. So we are measuring for 30 communities. And for each of them, they're saying population around 10,000 each, because the communities may be like the community should be almost equally large or small. Like that's also because if it's a very large community, number of thefts we kind of can see that if it's a large community, it should have more thefts. If it's a small community, it should have smaller thefts. So to make everything comparable, they should have each the same kind of population size. Like otherwise, it doesn't make any sense to compare between them. So we are taking 30 small communities. So the word small says that they are of equal size, kind of. Not exactly equal, but kind of equal size. So that's why n is 30. All right. That being done, the rest is easy. So we have to find 90% CI. So that means C is 90%. That means ZC is 1.645, which we have learned. Let's get down to it. All right, so list your point estimate. So here point estimate. All right, point estimate of what? Point estimate of mu. That's always x bar, which is 138.5. Next, margin of error. So which one is called margin of error? That's the E thing. And we know the formula for that is ZC times sigma by square root of n. We have all those things in our hands. and you can put them in your calculator, and you'll find it's 12.7942. Next, find the confidence limits. I mean, that is a confidence interval. So the confidence limits, they are obviously x bar minus e, which is the lower limit, which is 138.5 minus 12.7942, which you can find as 125.7058, and the upper limit is x bar plus e, which shall be 151.2942, and that's it. Actually, we have part B. Okay, so let's also get on with the part B. So part B is like if you would like to be 85% confident and we are within 10 cases of population mean. All right, so this is a reverse kind of problem. So here they want E to be 10 and they want C to be 0.85. So that means we have to calculate ZC, which we have learned how to do that. And if you haven't, then you should be you should start that. So ZC shall be 1.435. This I'm not explaining how. So that is your job to learn how to do that. And if we have done that, then we know that E is ZC times sigma by square root of n. That means square root of n is ZC times sigma by E, which implies n equals ZC times sigma by E whole square. Now sigma is given here as 42.6. Sorry, sigma is given here as 42.6, and hence you know all the numbers, and you can find n is 37.63, which is, you take the higher number, so n is 38. That's it. Done.